발표 시작하도록 하겠습니다. From now on, I'm going to introduce you to simple data pre-processing and tokenization process for natural language processing practice. The table of contents is as follows. Set the purpose of this assignment, explain how you are going to solve them. We will compare the two tokenization methods, that simple tokenization and regular expression tokenize. Results derived from this data. We are going to do it in order. First, I'm going to check the overall data. You can check it with code, but it's not visually visible. So I checked it with Excel. As you can see, the Excel file contains articles from YTN, which is unique in that it is in descending order, and you can see that all articles were written at midnight. When analyzing data, you have to set a goal and go through the process of collecting data. But now there is a set file, so I think it would be okay to set a purpose by looking at the data file. I have set my sights on analyzing keywords reported by YTN for the 3 months from January 1, 2022 to March 31, taking inspiration from data here. If we expand this further and include data from other newspapers, we can analyze major keywords related to Korea or the world for a specific period of time or graph the newspaper's reporting tendency. Now that we have a purpose, let's get the articles column organized by date. This is what it looks like in the full screen. And this is what it looks like when I zoomed in on some. I can read the article better than before. As you can see, it is natural that the contents are different for each article and the format is different. Some have black squares and some are wrapped in square boxes. Before analyzing, you have to erase all the things you don't think you need so that you can analyze them properly later. So now let's look at the process through the code. First, get the library to call the function I'm going to use. Originally, all annotations were attached, but as the code was copied in PPT, there was a lot of space for annotations, which hindered the analysis of the code. So I removed the annotation, but the Assignment1 Moon.ipymb file has annotation, so please refer to it. My purpose is to pre-process data with regular expressions, tagging, and tokenization for data analysis later, and put it in Word box and analyze it. First, call all libraries associated with pre-processing. RE is a library that can use regular expressions. Pandas are for data processing. K-on-NL5 is for natural language processing in Korean, and the one below is for using tagging functions. There are several packages that can be tagged, but for example, OKT, Hanaanum, Koran, Act, so it's better to use several and compare them to choose a good one. NLTK is a library for natural language processing and called to use tweet tokenization. I use tweet tokenize because there was an article with a hashtag in it. I loaded the data file and assigned it to a variable called YTN. Let's check the data, and since we already saw in the Excel file, let's move on. Next, please define the pattern to use as a regular expression. Among regular expressions, tagging and tokenization, the order of use has not been decided, so you just have to make sure that the data you want comes out. I think it's more convenient to use regular expressions first to remove useless characters. When I define a list of patterns in order, the same square bracket word form as square bracket anchor. The word YTN. The first bracket will happen all the way to, or from the occurrence of the reference sign. Everything that is not Korean, not English, not numbers. and act. And this slide shows a function. It is a function that compares the data and patterns according to defined patterns and removes them if they match. Parameters include data frames, column names, and new column names. Create an empty list of data with the pattern removed. Read each row of the data frame from the first of origin text. Read the article corresponding to column or article. To column A or article in each row and assign it to text. Now before the phrase ends, the text checks whether it matches the pattern or not. And if there is a matching pattern, it will be blank and the pattern will be removed. The proceed article is included in the temporal list. And finally, a new column called B receives the data from the temporal list and adds the data frame. And if you return the data frame, it's complete. It's better to apply and check if the function works well. Also, I use the code below to convert the file to Excel and check it, because it was convenient to look at it on Excel. In my cases. Here's another list for the rest of the pre-processing. You can divide it within function, but if the value of the list changes, it will not be reflected unless it changes within the function, so the list is created with global variables. The term is used to remove meaningless words. Typically, there is a 조사 of Korean. However, depending on the purpose of the analysis, the terminology may vary, so be careful. The important keyword list is a list I made randomly. I said it earlier too. There are various packages for tagging in Korean, but each package has different performance, so some packages separate Corona into Ko and Luna, and others separate 국민의힘, that is one of the political groups in Korea, into 국민, 의, and him. So we made a separate list to maintain the form of keywords that we think are important. Below is the second function. The parameter will use a column of data files. I created each instance to use the Korean tagging function, tweet tokenization, and OKT. These range are another form of class, as class, so the class itself cannot use the function of the package itself. You need to create an instance to use it. Tokenize it and put it on the list called tokens. Merged tokens is a temporary list of tagged tokens. We are going to use loop schemas to analyze the morphemes of tokens, which we said earlier, depending on the tagging package you use, the form of the word may not be maintained. In the case of OKT, which I used, there was a tendency to separate the names of Korean political parties without recognizing them as one. So the names of the political parties were included in the important keywords earlier. Let's code. Before performing a morphemes analysis, compare whether the token matches the value in the important list and add it to the temporary list if there is a match. In this way, it is possible to maintain the form of keywords that can be measured. If you look at the else statement, you can do a morpheme analysis for each token, assign it to a morpheme and add it to the temporary list. After all the loop doors are turned, each time to get rid of the star words. In Korean, there are words called 조사 that express grammatical relationships with other words or complement meanings, and 조사 is attached to almost every word in the sentence. So even though 조사 exists a lot, it doesn't mean much. So you have to designate it as a non-term and remove as a subword and remove it in advance. Each above filter tokens. A code that removes tokens in merge tokens compared to the subword list. Since our processing has been completed, The function ends by returning filter tokens. Now apply the function and check the data once. I'm going to compare simple tokenization and regular expression tokenization for a moment before I proceed. Continue. To use simple tokenization, call the word tokenized function and the variable sim token and YTN token are declared. Sim token contains token processing of the original article, and YTN token contains tokens after pattern processing using regular expression. Here, the two words same as below were used to avoid overlapping values, and their own values were included in sim compare and YTN compare, respectively. For the convenience of comparison, only the first article was used. The next slide is the output of the results. The list above is sim compare and the list below is YTN compare. If you look at the list below, you can see that there is no JOSA and the period has been removed. That is, it may be seen that unnecessary characters for analysis have been removed. Now that it's pre-processed, I'm going to proceed with the analysis. The TF-IDF vector function is called to measure the frequency of occurrence of tokens. To make a vector, combine all the preprocessed tokens assigned to a word box called document. Create an instance called vectorizer to use the TF-IDF vector function. The documents are learned by TF-IDF converted into vectors and assigned to X. It extracts the attributes of the tokens, creates a list, and assigns it to picture names. The occurrence of each token is added to include the number of appearances of the token is in word score. Based on the frequency of occurrence contained in the word score, the same and frequency of occurrences as the characteristics of the token are sorted in descending order and assigned to sorted word scores. It outputs the top 5 tokens with a high frequency of occurrence. And next slide, the print the result. Looking at the result, 했습니다 has the second highest frequency of occurrence. But we can figure anything out with this word. Since our analysis purpose is keyword analysis, we decide to exclude those that are verbs. I'm going to tag in one more time like I did before, created filter documents to hold tokens that are not verbs. Tagging tokens to tagger point POS in the for syntax, tokens are usually placed in filter documents, excluding that the part of speech is a verb. The process afterwards is the same as before. At this time, you can see that the analysis is well done. Assuming that the pre-processing went well, you can see that the 5 words on the slide are keywords that YTN has focused on for 3 months. To go further, 후보, 국민, and 정부 keywords are political keywords, while Ukraine and Russia are keywords about international affairs. Therefore, it can be said that YTN sees domestic politics as the #1 topic and the international situation as the #2 topic. However, due to problems caused by tagging, regular expression sequences, and excluded verbs, this analysis cannot be said to be an accurate analysis. In the future, I will find more suitable morpheme analyzers, subword lists, and more general patterns, and organize functions so that other many articles can be processed together. That's the end of the presentation. Thank you.